Welcome to your final lesson of Chapter 8, in which we'll talk about geometric probability distributions. Now, geometric probability distributions don't have anything really to do with geometry, but I figured I'd throw some shapes out there just for your enjoyment. We'll start off with a few questions, and then we'll get into the rules and formulas of geometric distributions. The first question says, in Canton, Ohio, home of Mr. Z, it snows 25% of the time in January. Assume that each day is independent of each other and the probability of snowing on each day is the same. What is the probability that it doesn't snow until the fourth day? So to reword that a little bit, the first day that it snows is on the fourth day. So to help us answer this, I'll give you a little hint that says what has to happen the previous 3 days. So again, the first day that it snows is on the fourth day. So on the first day, it has to be no snow. On the second day, no snow. On the third day, no snow. And on the fourth day, it finally snows. And again, these 0.75s, I'm just taking 1 minus 0.25. If I type that in my calculator, I'm going to get 0.1055. All right, and again, that's the probability that it doesn't snow. Not that it doesn't snow until on the fourth day, but that the first day that it snows is on the fourth day. So the wording does get a little tricky here. This is not a binomial because I'm not giving you a fixed number of days. I'm not asking you what's the probability that it snows 1 out of the 4 days. All right, so you can kind of start to see where you're going to have some difficulties with this. So here's our second problem. They're after me, Lucky Charms. Lucky Charms claims that 1 in 5 boxes contain a prize. You really want the prize but don't like Lucky Charms, so you decide to buy boxes until you find the prize. What's the probability that it takes you 4 boxes until you find a prize? So the first thing is we need the probability of finding a prize, which is 1 out of 5, which is 0.2. So that's roughly saying 20% of all boxes contain a prize. So what's the probability it takes you 4 boxes until you find a prize? So again, the first prize happens on the 4th box. So what has to happen on the first 3 boxes is no prize, no prize, no prize, and then finally you find a prize. And if I type that in my calculator, I get 0.1024. Okay, now let's get into some formulas. Okay, geometric probability. Basically, you need to pause the video and write these 3 down. I'm going to go through them quickly. Each observation falls into success-failure. That's the same as binomial. Observations are independent. That's the same as binomial. The probability of success, P, remains constant. That's binomial. The main difference between binomial and geometric is here in number 4. The variable of interest is the number of trials to obtain the first success. Okay? So it's all failures until the last number. Okay? There's no fixed n. No fixed n. Okay. Now here are the formulas. All right? So our formulas are the first success is on the nth try. The first success is on the nth try. So we've got this little formula, probability that x equals n equals, parentheses, 1 minus p to the n minus 1 times p. Seems like a difficult. You got exponents, you got subtraction. It seems a little tricky. But 1 minus p is just the probability of failure. Okay? And n minus 1, n is the total number, or not the total number, but the number until the number that the first success happens. So n minus 1 is just all failures except last one. Okay, so if I'm trying to do it on the 5th try, then the first 4 have to be failures. And then this P right here, that's just one success. Or it's really the probability of success. And it happens at the very end. Okay, so the formula, even though it looks kind of nasty, is significantly easier. here's your formula for mean and standard deviation. The mean is 1 over p, and the standard deviation is the square root of 1 minus p over p squared. Okay, now we'll walk through an example, do some problems, and be done. A basketball player hits 76% of his free throws. He shoots until he misses. Complete the chart to find the probability that the first miss will occur on the nth free throw and the cumulative probability that the player will miss on or before the nth free throw. Okay, so first thing I'm looking at is P. Now, it is not 0.76. It's actually 0.24. It's actually the probability of a miss because he's basically going to shoot until he misses. So I'm concerned with misses in this case. Look, first miss. All right, find the expected number of free throws to miss the first free throw. All right, now, so if x equals, or if n equals 1, that means I'm going to miss on the first free throw. Well, that's pretty obvious, 0.24. That's the probability that I miss on the first. The first miss happens on the first free throw. The cumulative probability is 0.24. Okay, now, the probability that my first miss is my second free throw. Again, not that I miss my second free throw, but that the first time I miss is my second free throw. So that's going to be 0.76, which means I made the first, and then I missed the second. Okay, so we get 0.182. We'll go to 3 just so they can fit. 0.182. And I add that to the previous 0.24, and I get the cumulative probability of 0.422. Okay, what's the probability that my first miss is on the third shot? So again, I'm shooting, and I'm going to keep shooting until I miss, and the first time I miss happens on the third shot. So the first one is a make. Oops. The first one is a make. Point. Yikes, having some difficulties here. All right. 0.76. The second one's a make, 0.76, and the last one's a miss, 0.24, and I end up with 0.139. 0.139. Okay, add that to the other two, 0.24 plus 0.422 plus 0.139, and you get a cumulative probability of, whoops, I'm sorry, you're just going to add 0.422 plus 0.139. 0.561. That's the sum of basically these three here. This plus this plus this. Okay, what's the probability that my first miss is on the fourth shot? So I got to miss the I got to make the first one. Sorry. I got to make the second one. I got to make the third, and then finally I miss the fourth. 0.24, and that's 0.105. Okay, and the cumulative probability would be the sum of those first four. 0.24 plus 0.182 plus 0.139 plus 0.105. And I'm going to get 0.666. Okay, we'll do one more, even though it goes to 6. So, again, if n is 5, that means that my first miss is on the 5th shot. So, we can kind of shortcut this and use the formula. 0.76. Now, if my first miss is on my 5th shot, that means the first 4 shots, 0.76 to the 4th, were makes, and then I have one miss at the end, 0.080, or we'll just call that 0.08, and that cumulative probability is 0.746. Okay, and basically this goes on and on. Now, the expected number of free throws for the first miss. Expected is mean. The mean of a geometric distribution is 1 over p. It's 1 over 0.24, which is 4.17. So I would expect to shoot about 4.17 shots before I miss. That's what that number means. What is the probability that it takes 3 attempts for the first miss? That we already did. All right. But I'll write it out according to the formula. That's the probability that x equals 3. Again, 3 attempts until I miss, basically. So that's going to be 0.76, which is a make. I'm going to make the first two, and I'm going to miss the last one, and I get 0.139. Okay, what is the probability that it takes 5 or less attempts for the first miss? Well, that's this cumulative probability here. All right, so it's basically 0.746 is my answer. But if I were to do that out the long way, that's basically the probability that my first miss is on the first shot, or my first miss is on the second shot, or my first miss is on the third, or my first miss is on the fourth, or my first miss is on the fifth. All right? Now, what is the probability that it takes more than 5 attempts for the first miss shot? That's 5. That's more than 5, so that's basically 6 or more. Well, I've got 5 or less, so it's basically 1 minus 0.746, and I get 0.254.